Hi friends, welcome to this fifth video on coding theory. This video will introduce you to the technique of decoding words. Come on, let's get started. What is meant by decoding words? First we will see what is meant by a decoder. It is nothing but a device which transforms the encoded message into the original form that can be understood by any of the receiver. By choosing a suitable encoder and decoder, it may be possible to detect the distortions in the message which is happening due to the original message due to the noise in the channel, and we will be able to correct it. The first part of the quantity was covered in the video in the previous versions, like how to encode the words. This was the quantity which we saw in our prior video. Now this video will deal with the technique of the decoding words. So this portion is what we are going to concentrate on. We have now received the encoded word. Now how to unwrap it and then receive what is going to be the original message is going to be the concept which we are going to now look for. So for which we will be using a matrix called as H. This H is referred as the parity check matrix. It provides a decoding scheme that can correct a single error. Okay, how many errors it can correct? Only one single error in the transmission. And how does this H look like? It is of the format A transpose augmented with IN minus M. We will have to keep a note that H does not contain a column of only 0. So if it is going to be a matrix of this format, no column over here of H as all the elements has zeros. So no column of H is going to contain all zeros. And the second point is to note that no two columns of H are the same. So every column is going to be unique or different from that of the other. So no two columns are going to be identical in nature. This property of H will help us to detect the error and to correct the error, that is a single error which has happened during the transmission. So the technique actually goes like this. So for encoding the word, what we will have to do is we will have to compute H into R transpose for every received word R. So we will be computing H into R transpose for the received word R. The outcome of which we will be referring as syndrome. Now we go take our H and see this syndrome is matching to which column of H. So we check column wise and see where this syndrome is going to actually match with. This position is where the element has changed. Say suppose this is going to be the third column is going to match with the syndrome which we have got, which means that the element in the third position of your received word has changed. So if the element in that corresponding position is going to be 1, change it to 0, and if it is 0, then you change it to 1 because it has changed, right? So now there is going to be only single error. So the option is if 1 is there, change it to 0, and if 0 is there, change it to 1. Now the quantity which we receive in hand will now refer to the decoded word. So that is half work done, and now what is going to be the original word, how to get it from the decoded word. We know that the string transmission used for is going to be b power m to b power n, which means b power m is going to be my original data. This is going to be my original word. The original word is going to be a string of length m. So starting from the beginning, you just pull out the m elements of your string. Okay, from the original word can be extracted counting m position from the beginning of the string, and this will refer to the original word. Now what happens if all the columns of the syndrome which we get is going to be zeros? In which case we say that we know the two properties of H. What are the properties? H does not contain a column of only zeros. So if the syndrome is 0, it will never match with the over here. And what does that refer to? It means that no error has happened during the transmission, and in which case you can the received word and the original word are going to be one and the same. So received and the original word are one and the same, no error has happened. If the syndrome is not identical with any column of H, so you are going to have a syndrome, and this syndrome you are going to check if whether it is matching with any columns of H. If it doesn't with any column of H, it is not identical. If it does not match with any column of H, then what does that mean? then it means that the received word cannot be uniquely decoded. So there are going to be many ways in which the error must have happened and we cannot get the original data out of it. So this is going to be the entire process that goes into the decoding of the word. We will make it crisp. So we will make it as 4 step. Compute H into R transpose. You collect the syndrome out of it and check which column of H is identical to the syndrome and change the element in that particular position, which gives you the decoded word. And from the decoded word, collect the first M position, that will give you the original word. So these are going to be the 4 steps which we are going to follow for decoding any word. Okay, come on, we will move on to apply these quantities to a problem. The things which we need to keep in mind before computation is E is the encoding function, which takes a string of length m to a string of length n. So the original string is going to be of length m. So this is going to be my m, and the remaining part over here is going to be your quantity which has been appended. This is going to be your parity check matrix which will be appended, so that the entire string now becomes a length of n. So this part is your original word, and this is your parity check matrix which has been appended to it. And we know that the generator matrix G is of the format IM augmented with A. The parity check matrix is going to be H, and it is A transpose augmented with IN minus M. And for each of the received word R, we will be computing H into R transpose. Keeping all these 4 points in mind, we move on to apply them to problem. Given the generated matrix G, which has been given of this format, corresponding to the encoding function, the encoding function has been given from B3 to B6, find the corresponding parity check matrix H and use it to decode the following received word, and from the received word find the original message. So we have been given 4 subdivisions, 1, 2, 3, 4, which we are going to work on. The quantity is G has been given, E has been given. E is going to be from B power M to B power M. So from over here, your M is equal to 3, your N is equal to 6. So your M minus N is going to be 6 minus 3, which is going to be 3. So what is going to be my G now? G is going to be IM augmented with A. So what is this IM? So this is nothing but my IM. M is going to be 3. I3 augmented with A. What is I3? I3 is the identity matrix of order 3. What will be the identity matrix of order 3? 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is my I3, and this has to be attached with something called as A, augmented with A. So now we will locate this in our G. In our G we find 1, 0, 0, 0, 1, 0, 0, 0, 1 over here. So the imaginary line is drawn over here, so that this part represents your IM, and this part over here is going to represent your A. Okay, so the second part is going to be your A. So what is going to be my A? A is going to be 1, 1, 0, 0, 1, 1, 1, 0, 1. So this A I have extracted now. Now I am going to form my parity check matrix H. What is the format for H? H is given by A transpose augmented with IN minus M. What is N minus M? Sorry, for this is going to be N minus M. N is going to be the bigger quantity. So N minus M is going to be I3. So I am going to fix my A transpose first and then append it with I3 next. So what is going to be A transpose? This is my A. So let me compute my A transpose by interchanging the rows with columns and columns with rows. So it becomes, make it ulta pulta way, 1, 0, 1. The first column becomes the first row, 1, 1, 0, 0, 1, 1. So this is going to be my A transpose. Now write your A transpose first, 1, 0, 1, 1, 1, 0, 0, 1, 1, and append it with I3. What is going to be I3? I3 is going to be this, which is going to be given as 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 0, 1, 0, 0 0 1. So I have my H ready now. So for every of the resid word, I will be using this H to compute what is going to be H into R transpose. We will decode the words one after the other. My first word which has been given to me for as a received word is going to be 111101. So now this represents my R. So what is going to be my R transpose? R transpose will be 111101. Okay, so this is going to be your R transpose. So I have my R transpose. What is the formula for your decoding? H into R transpose. So mark it as 1 0 1 1 0 0 1 1 0 0 1 0 0 1 1 0 0 1. So this is my H. I will have to multiply this H with my R transpose 1 1 1 1 0 1. The matrix multiplication is going to be our usual way, a particular row with that of your column, and you need to keep in mind 1 into 1 will be 1, 0 into 0, 1 into 0, 0 into 1, everything else will be 0, and we will be doing binary operation where our 0 plus 1 will be equal to 1 and 1 plus 0 will be equal to 1. 0 plus 0 will be equal to 0 and 1 plus 1 will also be equal to 0. So this is a binary addition which we will be following over here. So what you will be having for the first element is 1 into 1 is 1 plus 0 into 1 will be 0 plus 1 into 1 will be 1 plus 1 into 1 will be 1 plus 0 into 0 will be 0 plus 0 into 1 will be 0. So that makes my first element over here. Now I shift the quantity for my second row with that of the column over here in the same way, and I work for the element 1 into 1 is 1 plus 1 into 1 is 1 plus 0 into 1 is 0, 0 into 1 is 0, 1 into 0 is 0, 0 into 1 is 0. Now we move on with our third column over here, third row over here, and the same column over here. 0 into 1 is 1, 1 into 1, 0 into 1 will be 0, 0 into 1 is 0, 1 into 1 is 1, 1 into 1 is 1, 0 into 1 is 0, 0 into 0 is 0, 1 into 1 will be 1. So this will lead me to 1, 2, 3. 1 plus 1, we know that that is 0. 0 plus 1 is going to be 1. So the first element over here is going to be 1 for me. 1, 2, 2 1s are there. 1 plus 1 makes it as 0. So the second element is going to be 0 for me. 1, 2, 3, 3 1s. 1 plus 1 is 2. But 2 will now give me 0 when in binary addition. Now again this is going to be 0. 0 plus 1 will now make it as 1. So the quantity which I have as your answer is going to be 101. This is called as the syndrome. This we refer as syndrome. Now we move with this syndrome and check where is this 101 identical with which column. Okay, 1 1 0, is it identical? No. 0 1 1, is it identical? No. 1 0 1, yes, we find it over here. So it is identical with this position. 1 0 1 is going to be identical with this position. What is this position? 1 2 3. So your syndrome now matches the third column of your H. This means the element in the third position has been altered. So what is going to be my word 1? Our received word is 1 1 1 1 0 1. What is the element in the third position? Element 1 2 3. So this is going to be the position. So the element in this position has been altered. What is the quantity? Since it is binary, 1 has to be replaced with 0 and 0 has to be replaced with 1. Therefore, what will happen is my decoded word will be, now I change the element in the third position so that 1 will now become 0 and the remaining quantities will remain as such. And now I have found out the decoded word, how to find the original message, original word. What is going to be the length of the original word? We know that it is going to be originally a string of length 3. So from this extract just the 3 position 1 2 3, this 3 positions alone. So if I extract these 3 position, what is going to be my original word? My original word will be 1 1 0. So this is how we are going to work on the remaining pair of elements. So this is my first word. Now let me decode the remaining words quickly so you can do it along with me. So for the word B, which is going to be 1 0 0 1 0 0, my H into R transpose will be 1 0 1 1 0 0, which is going to be 1 1 0 0 1 0 and 0 1 1 0 0 1. And then you flip your R because this is going to be my R transpose 1 0 0 1 0 0. So this is going to be my R transpose. When I do the multiplication, I have it as 1 into 1 as 1. The remaining quantities are 0. Let me check this position, which is going to be 1 into 1 is going to be 1 and the remaining positions are going to be 0. Now going for the second line, 1 into 1 is going to be 1. Let me check for this element 1 into this position is already 0, so that will be having the remaining quantities as 0. Let me check for the next quantity, 1 into 0, this makes it as 0, 1 into 0, that makes it as 0, so it is going to be 0 over here. So what I have is 1 plus 1. What is 1 plus 1? 1 plus 1 is going to be 0, 1, 0. So this is going to be my syndrome. Now I'll have to check syndrome. So I'll have to check which column of H matches with my syndrome. So syndrome is 0, 1, 0, 0, 1, 0. It is present over here, 0, 1, 0. What is the position of this? This is 1, 2, 3, 4, 5. So element in 5th position has been altered. So I will change the element in the 5th position, 1 2 3 4 5. So this element has now to be changed for, so the decoded word will now be 1 0 0 1. I changed the 0 as 1, so this will be my decoded word. And what is going to be my original word? Original word is going to be a string of length 3 because B3 is going to be my encrypting function over here. So I collect the first 3 position. What are going to be the first 3 position? 1 0 0. So my original word is 1 0 0. So I have now encoded 2 words. You can proceed in the same way to encode the remaining words also. We will quickly move on with the next one. So element number C. For C, I have my received word as 1 1 1 1 0 0. So my H into R transpose will be 1 0 1 1 0 0 1 1 0 0 1 0 0 1 1 0 0 1. And now flip your R, 1 1 1 1 0 0. Now this has to be multiplied, so you will have to concentrate on 1 2 3 4. 1 into 1 is 1 and 1 into 0 is 0. 1 into 1 is 1. and 1 into 1 is going to be 1. The remaining positions are 0. The remaining second line, 1 into 1, we know that only ones are present, 1 into 1 will be there. The remaining quantity, either mismatches of 0 1 and 1 0, will make it as 0, so you need not have to bother about it. 1 into 1 is going to be 1, 1 into 0 0, 0 into 1 is 0, 1 into 0 is 0, and the remaining things goes 0. 1 into 1 is going to be 1, and 1 into 1 is going to be 1. This 1 is here but a 0 over here, so this completes the quantity. 1 plus 1 is 0, 0 plus 1 is 1, 1 plus 1 is 0, and 1 plus 1 is 0. So the syndrome is 1 0 0. Now we will see where this matches 1 0 0. 1 0 0 is going to be over here, 1 0 0. So this is the position number. What is the position number? 1 2 3 4, fourth position, 1 2 3 4. So the element in the fourth position has now been changed. Therefore, what is going to be my decoded word? Decoded word will now be 1 1 1. Change your 1 as 0 and 0 0. And what is going to be the original word? From the original word, we want a string of length 3 from the base first 3 string or 3 position. So 1 1 1 is going to be my original word. We'll complete the problem with quickly moving on with decoding the last part of the received word, which is 0 1 0 1 0 0. So I do H into R transpose. H is going to be 1 0 1 1 0 0, 1 1 0 0 1 0, 0 1 1 0 0 1. The only part which we need to be careful about is going to be the matrix multiplication. You need to keep in mind only 1 into 1 will give you 1. So the other positions you can mark it as 0. So this position alone you check 1 into 0. So that makes it as 0. This fourth position you check 1 into 1. So there is going to be 1 1. Okay, now move on to the remaining quantities will become 0. 1 into 0. But this 1 into 1 will give me 1. And next this position has 1. But here it has 0. This position has 1. Here it has 0. So you need not have to bother. Now 1 into 1 is going to be 1. And the remaining positions are going to be okay. So now I have a syndrome 1 1 1. So we will go and check where is going to be the syndrome 1 1 1, the important point over here. So we see that none of the column of H has 1 1 1. Okay, so we see that the syndrome is not matching with any column of your H. So what do we conclude out of it? The received word cannot be decoded uniquely. So this is going to be the conclusion we find if you are not able to find a matching syndrome in your H. So I hope that this problem would have given you an insight on how to decode any received word. Just keep your idea clear about the formula H into R transpose. Fix your syndrome, identify the syndrome, change the element in that position, and abstract the original word from your string encoding function. How many ever positions are there in your encoding function, the original word will be extracted it from the starting position. So this is going to be the way in which a decoding word will work. I hope this video was clear about the concepts of it. Please do ping me if you have any doubts on this regarding. Happy learning, keep learning.